Hi, I'm Richard here at EVTV, and we are with Danu, and we are getting ready to start Wang Rever's PowerSafe 100 bill. And this is the Wigman 72 by 36 by 30, the PowerSafe cabinet, and we just got this in. And we've actually had the other parts here for a while. This is the thing that takes some time for us to get. Every time we've ordered them, they say it's 4 to 6 weeks, and it's always ended up being about 6 weeks. So to shorten that time frame for the next PowerSafe build, we've got another one in. So we are ready to go for the next order, shortening our production time. Danny, what all do we have ready over here for the assembly?
So we have the unit struts that we have here. We're going to cut to size to fit inside our PowerSafe. We have the FPG board, right, Richard? It's a fiber grade, super solid.
FRP, fiberglass reinforced plastic.
Yeah.
And this is a great.
And this can take a lot of weight, and it's also non-conductive. So this is what we use to put the batteries on. Then we have the spring nuts and the custom-made steel anglers, and these are not any light objects either. They're pretty heavy. And also definitely the wheels. And how much weight can this take, Richard?
These are about 800 pounds of wheel, so you are over 3,000 pounds. Now, with these PowerSafes, it really, in certain areas of the country, you have power disruption. A lot of these units have gone to the islands, and that actually, where you add a few solar panels to this system, and you have almost like a personal power plant. And we have basically the technology, the core assembly process now to build these here. And we'll have another one ready. If somebody would like to place an order, we can put you on the list. And we are going to start here on this one on April 3rd.
Today.
And we're going to see what the assembly time is on that. And hopefully, get it shortened down a little bit.
Definitely.
Just for your information, there are about 500 parts in this assembly. So it is, takes a little management, a little bit of planning out, but we are getting ready to go. So Wayne, you're on the docket, and you are now in production. And we're really looking forward to getting that sent to you. And that is pretty well about all I've got, Danny. Do you have anything to add to that?
We got our new workbench on wheels, so I think
we've set up a production rack. So basically, in assembly, you want to get all your parts together before you get started, because it's basically zero sum. You got to get it all together one way or another. So we're going to be cutting some fiberglass today, cutting some materials. Hopefully get the wheels on, and by the next video, we'll have an update on the assembly. So,
yep.
And these are the way it's going. I mean, we've done several pretty substantial power units with the Tesla battery. We have the core, technology down. We have the ability to communicate with the battery, monitoring a lot of the parameters. So we're ready to go here at EVTV.
The first order of business is to get some wheels on this Galco enclosure. This is a tough enclosure. It's 10 gauge steel. It's even tough to drill or to cut. But we're going to be handling about 1,000 pounds. Well, they're 56 pounds a piece. So 5, 6, 1,120 pounds just in battery cells. The enclosure itself weighs 428 pounds. And first thing we do is put it on some wheels so we can move it around and turn it different ways and perform different operations on it. But it's not something you just lean over. Here we have our 3 monkeys, an enormous gray football, and a waxed concrete floor in this case. And we have a safety supervisor we call Shop Cat or Shop Kitty. We actually have 2 shop cats. She's safety, the other one's quality assurance. And so there she is ever on the alert. supervising on her step ladder, she never knew her real ladder. And so we're going to mark some holes on the bottom and start drilling holes in this quite hard powder-coated steel. And Mr. Grosh is doing here further marking and drilling. We can get some wheels under it. These are like cast iron wheels. We found the rubber wheels, the weight of this actually flattened them a little. That made it hard to move around, but these hard cast iron wheels, it rolls quite freely. One of our viewers turned me on to that, but he found solid wheels to be a lot better than the polyurethanes or the rubber ones, either one. And we get a lot of suggestions like that from viewers. We learn more than we teach in many respects. And now that we've got the wheels on them, here we are. They're going to raise it back up on its feet and get it ready to start making the interior modifications, which are not a big research item around here anymore. We kind of worked out how to do that. And the angle iron and FRP grading. That FRP grid is actually sold as grading. It's chemically resistant, it's non-conductive, it lasts forever, it's virtually indestructible. And they make nice drain grates now. Familiar with seeing these grates always rusting away, because what they do is screen out stuff from water drainage. But these fiberglass reinforced plastic ones just don't corrode or react with chemicals or anything. So we're kind of using those as the shelves in the PowerSafe 100. We call it a PowerSafe because of the selection of this enclosure. It looks kind of like a gun safe to me when you get done. I'd like to use a gun safe. They're always painted a nice green or black with gold stuff on them, but they're even harder to drill through because they're safes. So this Wigman enclosure has, we look for something less expensive or lighter or that would still do the job, and we just don't have any confidence level in anything we found. They probably make the best, and they're actually made right over here in Illinois, but for some reason their 4 to 6 weeks is always 6, and so that's a little bit of an issue. We're not very well set up to be a manufactory, but if you look at it from a certain perspective, these 4 Wayne DeVeres, or for Walt Crumbly, this is a component in a larger system, and they don't want to deal with the things that you all and we deal with in building this. They want to buy this and plug it into a larger system. Walter's instances for a resort, and for Wayne's it's a private island getaway at Little Hog Cay in Antigua. And we are actually going to do several of these for some other people that are coming in now with similar things, and they tend to be remote areas where just having power is a big issue. Living without electric power, we're a little bit spoiled, frankly. Down in Venezuela, they have lost power. And in less than 3 days, the civilization is devolving. Rampant looting and gunfights in the streets with people looting places. And I guess I kind of understand that for food and water and necessaries. But they're looting for electrical appliances. There's nothing to plug them into. They've got no power. What's that about? So it's we've got about 130 years in all of human history with electricity. And at this point, we're not really functional without it. And go live somewhere for 3 years or 3 days without electricity, and see what I'm saying. It's non-trivial. It's just built into so much of our lives. Almost everything we do involves electricity. I think we can get a significant percentage of it directly from the sun with the right combination of technology. Okay, we are here with James Grosh and Wayne DeVere's PowerSafe 100. How are we coming, James?
Coming good. We from the last time we got the inverter in, strapped. We have our harnesses in. We're testing the batteries to make sure they're all leveled. Danny did that today with our V2. He connected these two and brought them down together, and then went over there on the other side and brought those down. And then we also connected our Reblin cable and got that drilled in.
Okay. So you put in Unistrut.
Yes, sir. Unistrut.
Black angle iron, steel.
Steel
painted,
angle iron. Yes, sir.
And our FRP.
Fiber grate.
Fiber grate.
Yep. 1 inch. Yep.
And
Aluminum anglers on each side to keep them in place.
we have 20 Tesla Model S modules in a 2S 10P, 10 in parallel, two in series, and 10 sets of those in parallel, for 48 volts. And they're nominally 5.5 kilowatts, so that'd be about 110 kilowatt hours. We don't fill them up all the way, maybe 4.1 volts. And so we call this the PowerSafe 100. You've got the harnesses on.
Yep.
Got a Reblin connector here. And we have all these balanced at 23.87 volts each.
Yes, sir.
And so we're kind of ready to start. He's put the inverter, the Signature 15 kilowatt, on top. And we're producing this for a Mr. Wayne DeVere's. We're going to ship it to New York, but it's going to Antigua. And he has an island there with a home and a dock and looks
Blue
like
waters.
paradise.
Yeah.
Except on days when they don't have electricity, which is all of them since his solar system burnt to the ground.
Doesn't have a lot of electricity then.
Yeah, then it's not quite paradise. And he's going to build a state-of-the-art system. We kind of exist to enable do-it-yourselfers to build their own one of this. But in some sense, if you view this whole thing as a component, he is designing a larger thing, a whole solar system for his island. And we're not really in the battery assembly business. We did one of these as a what-if project to see what a 100 kilowatt hour battery system looked like. And it allowed us to do some fairly extensive tests of the Signature inverter and our BMS controller to check out some edge cases. And it turned into an education, actually.
Yes, it did.
For me, anyway. And so that became our test bed, which we have in the other room. Walter Crumbly is who the conversation started with. He has a new home he's building in Costa Rica, but he actually has several cabins and a barn, restaurant, kind of like a little resort there. And they have 30 power outages a month. That sounds like one a day to me.
Yeah, that's a little
And,
intense.
you know, there's a lot of areas of the world that are like that, the Philippine Islands.
Yeah.
Of course, Wayne doesn't have any electricity until he gets this back up. We're going to send this to New York, and he's going to get it all working there, his whole system, and then ship it to Antigua.
Wow.
And reassemble it there. So we're getting a lot of inquiries about these, which is awkward for us. We do research and development and videos, and we do produce a few little things that simply aren't available, so we design a circuit board and have it built in China and so on and so forth. The V2 of our controller we kind of packaged because of a lot of product support on the kit. I don't really like kits. There's a reason why. Almost every application of everything is different. I've had people call and basically want this done for a 72-foot catamaran. You know how many 72 feet catamarans I've been on in my life ever?
0?
Yeah, less than one.
Less than 1.
And there's some magic thing that everybody thinks that you can, if you know something about one thing, you must know something about everything. Actually, I do. Most of it's wrong, but that's not the point. The point is, we're trying to do some pieces that will enable you to safely use the Tesla battery modules, for example. And that kind of led us to the wiring for that little serial daisy chain. Is so confusing to me. We had cables made up professionally, and those have been a big seller because our viewers have the same problem.
Yeah.
And so we do that sort of enabling components in the hopes that you will innovate and create and design new systems and further the cause, not by getting on TV and chanting nonsense in a really loud voice because you really, really, really believe it. Having no experience or knowledge of the topic doesn't seem to slow these people down. But what we learned with the electric cars, actually what I knew going in, was that kind of advocacy is not only useless, but often counterproductive. You only seek to alienate the people that might help you. And to further alienate those that weren't ever going to. And that's not a good thing. There was one guy out in California to a meeting about electric vehicles in Southern California. And they spent 3 days just raging about how everyone ought to drive an electric car. On Sunday afternoon at the close of the convention, they were taking questions. He says, I'd just like to ask how many of you people drive an electric car out of the 800 that were there. 2 people raised their hands. And so we catered to and tried to recruit, aid, and abet and enable and empower people to make their own electric car. Now, that's not a path to having electric cars directly, but the acculturation or the building of some latent demand that would encourage manufacturers was very important. People have a bias against batteries because we know all about them.
Yeah.
With the advent of the lithium batteries, we knew it wrong. And to counter that, we had thousands of people building electric cars and showing them at shows and in their neighborhood and in the local paper and down at the local high school and so forth. And that is a much more powerful form of communication than getting on TV and chanting about stuff. We tend to discount what we hear, less so what we see. And if we get to experience it ourselves and talk to the guy who built it, that's more persuasive yet. And I can assure you that with a couple of notably weird exceptions, almost every viewer we ever talked to or saw their car, many of them actually brought them here to Cape Girardeau. We had an annual convention of them there for a while. Almost every single one of them was a better looking car than I ever built. We demonstrated
How to do
vendors' equipment, how you put it together and how you configured it and how you could do an overall car design. But my wiring looks like rats have been in there. And one guy from St. Louis had every single wire across the firewall parallel, and then it made a curve and went down. It's all shellac.
That's some detail.
They have a serious attention to detail. We're doing some serious show cars. And it always made me embarrassed to even open the hood of mine around them. So that's not unusual. Most of our viewers do better work than we do as far as the fit, finish, and meticulous fabrication. And so we're in a kind of a strange thing now because we did a couple of these. We're getting a lot of calls about them. But a lot of the calls go something like this. Jack, I'd like to have a PowerSafe 100, but when I add up all the costs of the things in it, it doesn't exactly equal what you're asking for it.
Interesting.
I'm like, well, there's a reason for that. Number one, this pony doesn't butt for free. And number two, it takes us 4 or 5 weeks to build one, and a lot of labor and a lot of trouble. And we're not really set up to be a factory. That's not what we do. But good news, every component in it, with the exception of some ordinary hardware items, angle irons we don't carry. I don't think we offer the wheels, but almost everything else is already in the store as components you can use to design your own system. They're like, well, that's great news. Could you just give me a list of everything I need and tell me how to put it together? Because I don't really know much about that.
Yeah.
And I'm like, no, I can't do that. Well, why not? Because I don't know what you need. I don't even know what a 72-foot catamaran looks like. And, you know, everybody's got a different application. They want this exactly, but with just a few changes. Because, see, they start in on this on the phone, and they want me to design them a system on the telephone. I wish I were that good. I'm not. There's a little more to it than that.
Yes, sir.
And you're on an adventure, and it's very educational.
Definitely.
And it's very personally rewarding, but it is not without work or errors.
No, it is not.
And we make them here.
Cuts.
It's expensive, I suppose. Although if you check the price of bass meat or deer meat or duck meat, all those duck hunters, what they've got invested in actually going and getting to shoot at one duck. Or the bass fisherman and his boat and his trailer and his equipment and his depth finder, and it goes on and on. As hobbies go, this is not particularly any more expensive, and it does have some utility. You're not going to pay it back with your savings on your utility bills, but what are they going to do with duck meat and bass meat? It's at least useful. And so it's a good hobby, it's educational, and you may just come up with something, or maybe a whole business, where you manufacture something. I don't want to be a manufacturer. So that's kind of the drill. Our pricing overall on everything is not so much that we make a lot of money on it. We do. I've always made a lot of money. I don't know why.
Just a hobby?
It's designed where if somebody did want to do that, and they did it at the same price or maybe a little lower, it would handle all the loading of a building and employees and a business to sell those. That's kind of how it's designed. We're not really going to do that except in select cases. There is a thing called replication. On my Cadillac, for example, I wanted the fuel gauge to show the battery state of charge. And their gauge set is driven by CAN. And I knew a little bit about CAN, not as much as I do now at the time. But the time and effort to do that was not proximate to the utility I would get from having a gauge in the dash that worked, because I can make another gauge and get it to work very simply with my battery. In other words, it's just too much time and trouble for one
person. Yep.
Escalade. I don't really see doing a second one, and I haven't seen anybody do one since.
Less than one.
So it's not like electric Escalades are going to get to be the thing.
Yeah.
So that's the
Replication.
situation. The Tesla drive unit, on the other hand, we sold a dozen or so of those at like $25,000. Took a lot of time and effort to reverse engineer that, select components, get them all working together, a wire harness, and so forth. But it was replicatable. Other people I could envision wanting to do that. So I wanted to do it for me. It could only be worthwhile if I could replicate it and sell it to other people. And these tend to be pretty low volume deals. Not everybody is eligible to buy a $25,000 drive frame. So there you go. More recently, we've been about batteries, and we've been able to produce things for some less money. But again, if I want to use them, it's too difficult to do the time and effort to make one. But if other people would be interested in it too, and I could replicate it, even in small volumes of a few hundred, that would then be worthwhile. And so that's the concept. In doing all that, I don't want to kill off the dreams of others. I had a conversation with Josh Wardell. He was doing the CAN
Adapter.
yeah,
capture.
he wanted to do a CAN adapter for his guys in his
Forum.
discussion forum topic, and then here I was doing one, and I said, well, mine's going to be $300, Josh. That leaves plenty of room for you to do one, and
Yeah.
it's fine with me that you do it. Well, he couldn't get over that. Why would it be fine with you? I said, well, people do it all the time. It's
It's how business.
my objective is not to crush the
Hopes and dreams.
hopes and dreams of the bottom feeders. It's to not have to deal with them very much, which if you'll build one, I won't have to.
Yeah.
And I won't have to deal with them. It's not that I won't have to do the adapter. There's plenty of people that I need them and want them. The issue is kind of the same one of I can add up all these things and do it. Well, we're back to fourth grade arithmetic and the nuns. They don't count everything, like their time chasing down all the parts and their time putting it together and all that. If you're wanting to do that for the education and to have the project, I'm all for that. We have a lot of regular customers that started out by saying, Jack, I can do that for a quarter of what you're charging. And I'm like, so why aren't you done yet?
Go out and do it, yeah.
Go do it. And they'll go do it. And as it turns out, if you count everything, my $100 device that they could do for 25
However much.
wound up being more like 75 or 80. They saved a little bit, but it wasn't quite what they thought. And we go through this with the same guy a second time. And he's certain to notify me that he can do it for less than we're charging, which I kind of admit. And about the third time, he becomes one of my lifelong customers because he's been through this twice. And he can't replicate it.
Yeah.
He doesn't have the channel. He doesn't have the viewership. Yeah, the internet's, everybody can reach you except nobody knows about you. And it generally winds up being a disappointment. So we have people like Stan Cloyd. He buys things from me. I'm not even sure he knows what they are. It's just something new in the store, and he's got to have one. He's got them all piled up in a room, and some he even uses. But he's a gadget guy.
Yeah.
He likes our show, and he wants to support us, and he just any shiny bauble. He's kind of like me. Any shiny bauble in the store
Gotta
is
have it.
exactly what he was thinking, you know.
What's his name again?
Stan Cloyd.
Cloyd, okay. Keep an eye out if he gets an order.
This is advanced to the point where he called me and wanted me to order something we don't even carry and don't even believe in. An MPPT charge controller. Because we had dealt with this company for inverters, and I ordered it for him. And then DHL informed him that for another $472, they would even deliver it to him. He's like, I thought you already charged me shipping. I said, I did, Stan.
Is it customs?
Yeah, it turned out it was a customs duty. The Trump 25% has apparently clicked in. And so the good old days of Chinese solar equipment for cheap are kind of gone. We do have a shipment of Singanir 15 kilowatt inverters coming in, but I'm sorry, I don't think they'll be in the store for the price. We've had them and have sold them in the past because I'm pretty sure DHL is going to have a little something to say to me about that shipment. And so there we go. Things are changing. Maybe they'll do a trade deal someday. That would be cool. So that's a little bit about what we do and why we do it. We're not anxious to build a lot of these because it kind of shuts us down for a couple of weeks.
It does.
On the other hand, then we have James and Danny working on it, and I'm constantly pulling them off to do something I think is fun, and so it goes a little slowly. But this one they're making good progress on, and I'm hoping to see this finished in another, 6 months?
Maybe a little less than that.
Maybe a little less.
See how the next video goes.
Okay, good. Well, it looks gorgeous. Y'all are learning to do it very neatly, if nothing else.
Yes, sir.
And so we'll get this finished up and off to Mr. Reavers. No, we don't do it for the price of the components. And then the guy was like, that sounds great, except I don't know how to do all that. And could you give me a list of what I need?
We have a video.
No, I can't.
Yeah.
Number one, I don't know what you need. What they're wanting to do is get everything in one order. I've never gotten everything in one order. You get what you think you need, and then you have to go back and get something else. And we're constantly dealing with that ourselves. It's an issue. But that's, you kind of have to design your own. We have done a few of these. It's basically because they have kind of high visibility needs. They're doing something very interesting on a larger scale. And if I'll build them one, they're going to show it to people. And hopefully we're going to advance a little different way of dealing with solar and batteries, and hopefully change the world. I'm an old guy. I made my fortune 20 years ago for the third time. I'll tell you something. You can't wear but one pair of pants at a time. If you don't believe me, try this. Go put on 4 pair and try to walk around the block. It's an adventure. You can only eat so much and drink so much before you're 300 pounds like me and kind of lurching from chair to chair. And you can't really live in but one house at a time. I tried having several, and just the maintenance and the logistics of having 2 or 3 in 2 or 3 different states will drive you crazy. And so that's not why the world gives you money, and that's not what you do with it. So that's all a little different from what you imagine. We're like Steven Spielberg's cartoon, Pinky and the Brain. What are we going to do today, Pinky?
Take over the
Brain. We're going to try to take over the world. Actually, I don't want the world. You can't give it to me. If you do, I'll give it back. But we're going to try to change the world. And at my age, a solution needs to be to 4 or 5 problems at the same time. When I was young, I could afford to spend my time on a solution to a single problem. These decades, I want a little more. And so I consider the electric vehicle the solution to 4 or 5 or maybe 6 problems simultaneously. And similarly, solar power. But I was alarmed, as I said in the last video, 20 years after I put one in, to find so little progress. They are doing something kind of neat right now that I approve of. Several companies, Panasonic most notably, but also Solaria and SunPower, are all, as of March, this is the middle of April, but by the end of March, they were all shipping what they're calling AC modules. And so about $495, Solaria has a 345 watt panel with a microinverter, grid adaptive inverter
on it.
already assembled and mounted on the back of the panel.
Well, that's crazy.
And they're calling
like
them
that.
AC modules. This is going to be how solar's done.
Yeah.
Really from here on out. And so
cool.
you're going to get AC power from your roof, and that's why we've been on and on about AC coupling into battery storage. And I've gone over several reasons why that all is. The basic thing you have to get over is that in a sort of a fluke of the design of the universe, we wound up with a planet that rotates on its axis and tilts a little bit on its orbit and then wobbles that. And it's all part of God's plan, but it makes battery storage kind of a requisite if you want to power from the sun. And again, I don't think we can power the world with sun. Boy, there's a lot of talk about nuclear all of a sudden.
Yes, there
Did
is.
I cause that? Actually, Bill Gates did.
Did I cause?
And he's doing good work selling that story. But for you personally, there's a lot coming in the future about electrical rates, about electrical reliability, and about taxes on electricity, and so forth, where you might want to develop a little hobby of seeing how independent you can be in your home and generate your own power at the point of use using solar. And that would be even for a large home or a shop or a workshop or garage associated with your home. And that's who I'm looking to develop and innovate and create and extend and revise and all that to get to workable solutions at that level for being independent and not so at the mercy of a grid system that's now 130 years old and doesn't really make much sense. I did confirm with the Energy Information Administration website a couple of things. One is that residential is about a third, commercial is about a third, and industrial is maybe a tad less than that of our electric usage. But also, they kind of had a interesting number. They kind of separated the amount of electricity generated by the grid and the amount of electricity sold. And the difference was about 9.5%. Why would that be, James?
They use more of it?
You know what? They do use a little bit just to generate it.
Yeah.
They use a little on site, but the vast majority of it was losses in the line between the power plant and your meter. Now imagine a business where you charge customers what they ultimately receive, and 10% of what you ship disappears on the truck.
I wouldn't be too happy.
That wouldn't be too good. Well, that's what you're doing with a 130-year-old grid distribution design, and it's real. It's almost 10% of the electricity generated in the country is given off as heat in the transmission lines. And so that's not particularly good. Let's talk about something else. Cut. Okay, are we rolling? Okay, here we've got a pile of Dan Foss solar inverters, James.
Yeah.
Why would we have that?
We're looking to start on a new project, I'm guessing.
Mm-hmm. Well, kind of. Actually, the reason is I picked up 10 of them really cheap.
Oh.
And I'll share them with you. We'll probably have them in the store for around $1,000 or $1,100 each. They're a 4.4 kilowatt grid-tied inverter. The one notable thing is that it's grid-tied, and the second is that it uses a 300 to 400 volt battery input. And I suppose the third thing is that it's quite inexpensive. Apparently they had a contract with NATO. These are all 60 hertz inverters. I guess NATO is mostly 50 hertz. So I'm not sure what happened there, but these showed up
Somebody
brand
messed
new
up.
in the box and kind of inexpensive. And
Got 10 of them?
so, and they're 4.4 kilohertz grid-tied inverters. Not the latest and greatest. I think they came out, the DLX series, in about 2012 or 2013. Why would we be fooling with those? We do off-grid. Mm-hmm. Well, yes, we do. The obvious thing is that we could hook this up to a full battery pack and make an additional 4.4 kilowatts. And since they're grid tied, actually, we can line them up and run as many of them as we want. And as long as we've got a grid to sync to, we don't have to have these intercommunicated at all. They'll simply synchronize to the waveform and produce power. Well, that would be kind of crazy to take energy out of one battery and invert it and then feed it backwards through the inverter into the other battery. Well, that could be fun. We are prone to do things like that.
That are fun.
Just to watch everything heat up
Yeah.
and see what blows up. And we're going to do that. But here's the thinking. Let's talk about a couple of things. And they have to do with a time shifting and a peak shaving. The utility companies were kind of dragged kicking and screaming into the idea of net metering.
Yeah.
And net metering was a populist idea that if you produce power with solar and ran your meter backwards, that they should pay us for it. Mm-hmm. And they kind of had this forced on them by the legislatures in the states, and they don't like it at all. They're kind of like the Chinese. They want to sell you stuff, but they don't want to buy anything from you. And so, even if it's in their interest, it's just philosophically they can't deal with that. They had this come up in California recently about batteries, and a utility company spokesman actually said there is no way we're going to allow, and apparently he thinks he gets to allow, somebody to buy electricity from us at a low rate and sell it back to us at a high rate. Now that sounds like it makes sense, doesn't it? But only to a Californian. Which would be an alt-left libtard Democrat, no doubt.
No doubt.
Because they changed their story in mid-sentence to fit whatever they think you're thinking at the time. And it's just profound. Why does he have a low rate and a high rate? Well, when he talked the PUC and the legislature into it, it was because sometimes of the day demand is higher and they need to charge more for it, and sometimes of the day demand is lower and they can charge less for it. I'll buy that.
Sounds reasonable.
It isn't really. If you know anything about power plants, it's entirely nonsense. But I buy the narrative, and that's kind of how they do it. It isn't whether something is true; it's only something that you could argue, and it needs to hold water logically.
For a little bit.
So let's say it does. So why wouldn't they want somebody using electricity when they have too much of it, and producing electricity when they need it? You see, he's totally against that, even though that's exactly what he needs. You can't count on these people to even act in their own best interest.
Dangerous.
So there's a lot of stuff going on in Georgia. We've got a guy who pays 15.6 cents kilowatt hour from 7 a.m. till 11 p.m. and 3.5 cents kilowatt hour from 11 p.m. to 7 a.m. He wants to charge his batteries at night, would you believe, after 11 actually, and to run off the batteries during the day. Would you believe?
I'll believe.
There's another aspect. They've gotten very creative with their things. They want to do something called peak demand charges. And they have introduced this in the commercial end to fabulous success. They can take a company with a $100,000 a month utility bill and give them a discount from that bill if they'll just let them charge $250,000 a month. Such a deal.
Such a deal.
And how this works is we'll give you a lower rate if you sign up to this program, but peak demand, if you go above a certain peak level for more than 15 minutes, then you pay a higher rate. On page 56, you discover in 4-point type, it's a higher rate on the whole bill.
4-point type.
And so they are simply raking it in on commercial accounts using peak demand charges. This has worked so well, they really want to do it at the residential level as well. And so now in many states, if you do get a net metering account, or if you get a discount for your electric car, this is hilarious, you get a discount for it, except if you actually charge your car,
It goes.
a peak demand charge kicks in. Again, this is on page 22 in
point type.
4-point type, which is exactly how it's going to occur if you charge a car. And so they're gradually sneaking
Pushing
in
in,
these peak
yep.
demand charges at the residential level in Oregon, Northern California, Nevada. It's going to spread east. It's coming to a theater near you. Within a few years, you will pay a peak demand charges. And so let's talk about what a peak shaver would look like. It would monitor your usage from the grid, and if it got to a certain level, ideally below their peak threshold, for a certain amount of time, ideally less than the 15 minutes, you would kick on an inverter and battery that would provide some of the power so the grid never sees that peak. And as the requirement went down, then you would switch off your grid-tied inverter and recharge your battery slowly so as not to cause a peak. And that would be a peak shave device where the utility would see the power usage going up, and at a threshold just below your threshold for the building, it just gets chopped off for the time you need more power, and then it fall away after that. And to do that, you don't want an off-grid inverter, you want one that works with the grid. And so, experimentally, the Dan Foss scratches that itch, and from a full battery pack. We're going to have to do something else I'll talk later about for our 48-volt world. But this is where we're going with this. So what's needed there is a means to control these, and but most notably to measure power from the grid. Now there's all sorts of devices that will let you do that. Our Enphase has a gateway device that you can monitor that, and it will show up on their website. But would you believe their protocol to communicate that information is a state secret? That's proprietary information.
That's state secret.
All these solar guys are not interoperable. They want you to just buy stuff from their line. I have no problem with them having intellectual property as far as their device goes, but I haven't heard anything like this since the early 80s, where we're going to make the communications protocol a secret so we can only work with our devices. That's modems circa 1980. And they quickly learned that that was a quick direction to go towards bankruptcy and the sale of your office furniture at 10 cents on the dollar. Eventually they learned to play together and interoperate on their communications protocols. And I consider it a fatal flaw in the heart of all solar everywhere right now, and my cat does too, to not make their devices interoperable and their communication protocols open. We also have a Sense device. The thing about it, detecting and identifying appliances, is great fun for 15 minutes, largely useless. But their depiction of both our solar and our grid, power production and so forth, is not bad, but it's on their website. I can't really use it to control anything. And guess what? Their protocol is a secret too. So we need a device, and you need a device, to monitor AC power and correctly measure it, and to have communications interfaces via CAN and wireless and Bluetooth and so forth, to be able to use it with other equipment. Let's go take a look at that. What do you think, Cat? No, you can't eat James. Stay with us. Okay, we're a long ways from shipping any of this, but it's kind of something that Colin and I have been working on for 3 months. A lot of it's simply waiting for prototypes from China. We've made a new circuit board that are standard 1 each ESP32 CANdue with the 2 CAN ports on it plugs into. You normally see this as a shield. In this case, the main controller is actually a plug-in into the board. The board is kind of large because we've got several things on it. We need to have some isolation chips. We're going to be dealing with some powers, but not very big ones on the other side. The key to this is a Analog Devices ADE9000 chip, and we'll have a spec sheet for that on the website. It's a relatively new chip, 2017, and it does a remarkably accurate job of measuring current and voltage and active power and or real power and apparent power, voltamps, real power, watts, and reactive power, which you probably don't have a need for, but also frequency and power factor and total harmonic distortion of your waveform. And we're going to use this to measure power at the mains, the AC power. And we're very accustomed to measuring flows and so forth in DC, but in this case we're going to do it with AC. AC, of course, doesn't really have a polarity, and it doesn't really have a direction. The current flow is forward and backwards. However, when you use it to power equipment, you'll find that the current lags the voltage just a little bit, and so we can use that to detect the direction of the actual total current flow or power into or out of a device. In this case, our AC grid main entrance, or our PowerSafe 100, for example, Signir output. Because we're in an unusual situation in that we're going to both be taking power from it, but we're also going to be putting power back into it. And that is a little bit different from all the measurement equipment that's out there, and they tend to do it by using multiple sensors and so forth. We have the Sense device and have tested it, and I've kind of fallen in love with it. The thing about it identifying devices is fascinating for 15 minutes, and thereafter not very useful, or nearly as useful as they would say. But they do have a website where we can see both our load power and our solar power by using 4 sensors, one on the solar output and one on the mains. And that's fun to watch, but it doesn't work for us really, because all the protocols of communication are entirely closed. Now, I could probably reverse engineer that, but it's almost easier to do our own device. For one thing, we don't need 4 sensors. We can tell the direction of AC power flow by comparing the phase of the current and the voltage. And we can also, that's kind of what happens innately in this chip anyway, because it calculates power factor. What is power factor? Like DC power, if you multiplied your AC current by your AC voltage, you would think AC power. You don't exactly. You get apparent power, and that is simply volt amps. And in fact, they designate that measurement as VA, or volt amps. You'll often see inverters specified as VA instead of watts. That's because it's always a higher value than watts, so it looks like their inverter is bigger. The volt amps, or apparent power, times the power factor from 0 to 100% would give you your true power, or your active power, in watts. And that's caused by reactance. And there are two types of reactance: capacitive reactance and inductive reactance. Capacitive reactance would be if you were driving a switching power supply like a charger. It has a large input capacitor in it, and that is going to make the power factor altered. And so your active power, your active or true power, would be the current would lead the voltage. A capacitor resists a change in voltage, but can produce a tremendous amount of current. An inductive load, the voltage leads the current. And that's more commonly what you'll see, because all your fans and blower motors and so forth are really an inductive load. And so when you apply a voltage, those inductors, or those windings, resist a change in current flow, and so your current lags a bit your voltage waveform. We can take advantage of this in determining which direction the power is flowing, but you have to have a device that can simultaneously measure voltage and current and the phase angle of that. And this Analog Devices chip can do that. And it's designed to monitor 3 phases. Almost all the products we've seen on the market are designed for 3 phases and don't work very well measuring 2. Then there's some single phase devices that work on your 120 volt plug-in. And that's not what we're after either. We actually only have 1 phase coming into the building. It's 2 ends of a transformer with a center tap. And that is your 3 wires from the pole transformer. 2 of them are L1 and L2, are opposite ends of a secondary of a transformer, a step-down transformer. Typically 5,600 volts down to 240. But that transformer has a center tap that they also run into your panel, so that you can take 1 end of the transformer and the center tap and get half the voltage, or 120 volts AC. So we're going to use 2 phase inputs basically to measure the 180 degrees out of phase component of the device. I've got a problem with playing with circuit boards with 240 volts AC on it. 120 volts AC you can get a pretty serious shock from. 240 can blow your hand off your end of your arm if you get it just right. It's non-trivial. It's actually more dangerous than the 300 or 400 volts DC that we play with around here all the time. So I don't want any of that on my circuit board. And I need to power the board. This is a very small, low power transformer, and it's a step-down transformer. And it has 2 sets of leads. And one set you hook up, in our case, to neutral and one of the phases. Let's say L1 and neutral. That would give us 120 volts. That's going to step down the output leads to about 7 volts. It's actually a 115 to 6.3 volt transformer, and that is simply done by having a lot of windings on the AC phase side and a very few windings on the other side, and in this case it would be 115 divided by 6.3. What's that, Danu? Have to whip out the magic phone, the magic calculator, because I can't do 4th grade arithmetic, but 115 divided by 6.3 is 18.25. So for every turn on the output, you have 18.25 turns on the input, and that steps down the voltage from 120 volts to 7, or from 115 to 6.3. And we're going to hook that to a circuit breaker on L1 with one lead and the neutral with the other, and that'll give us about 7 volts AC out of here, and I can use that. I'm going to have to do it twice. So we're going to take 2 of these and put one on L1 to neutral, one on L2 to neutral, and then we're going to tie one end of each of these outputs together and use that as our neutral, if you like, for our voltage, and the other 2 will each have a relationship to that neutral of about 7 volts. On the board, I'm going to measure each of those separately, 7 volts, and use that to represent the 120 volts mathematically. But I also have a little rectifier on here, and I can take that 14 volt total, and that is within the range of my 12 volt regulator, which is on the multi-controller anyway. So if I can rectify that 14 volts AC down to a peak voltage that will be within the range of this device, our regulator, 12 volt regulator, I can power the board. So with 2 of these, I can sample the voltage of each phase, and I can power my board at the same time. No harm, no foul. This is another kind of transformer that you've seen many of. The Sense uses them and so forth. This is a little, what do they call this? SCT-013 is a part number. It is 100 amp to 50 milliamps. Now, it only has the secondary in it, a whole bunch, usually about 2,500 windings of very fine wire in one side of the device, the lower side actually. And our wire goes through there, and since we don't want to rewire a panel, they make them where they clamp on, and you can snap it together, and that will do it. What that puts out is the secondary. If you have 100 amps going through the wire, you'll get a 50 milliamp output. And it's actually on tip and ring of an audio cable. And so we can put that across a resistance and then measure the voltage across that resistor by that induced current in the secondary, and that will represent our current flow through the wire with appropriate scaling and mathematics. Actually, simple arithmetic. And so we have one of these for each of our phases, and we clamp it on. It has a direction. It's got printing on one side and not on the other. I've actually done the software where if you get them backwards, you hit a minus sign and enter, and it flips everything. But you do want them facing the same direction on each of the currents. And so that's how we sense current and voltage in our main circuit breaker panel. And we bring that into the board through this connector. I don't really do that. Here's the thing in an enclosure, and we simply have the boards mounted in the bottom and wired to little 3.5 millimeter audio jacks. Audio cables are, and of course our current flows on all this are going to be trivial, and they're not high voltage. We don't get 240 volts. We get 7 volts out of each of these, and we get a little trivial 50 milliamps of current, and with the resistors we have on the board, that winds up being about the same, 5 or 6 volts that we're actually measuring. By the time we scale that with resistors, it's between 0 and 1.1 volts on the input pins to the chip. So we can use very light audio jacks and cables that are relatively inexpensive, nicely pre-made. This one I kind of like because it has 3 screw terminals for sleeve, tip, and ring. This one is a little smaller, and you kind of solder them, and that's what we're actually going to produce with. And then you have audio cables that you can simply plug in to those jacks. They snap right in. It's a long established 3.5 millimeter audio standard, and it'll work great for this. This is not the final enclosure. We're still chopping on that. You can see here the 3 jacks. We carry all the voltage, both voltages, on one cable, tip, ring, and sleeve. Sleeve being the common, and the tip and the ring being the 2 7-volt outputs. And then these SETs come already pre-wired with audio cables, and tip and ring is the 2 ends of the secondary transformer that will produce 50 milliamps. I understand you get 50 milliamps if you're running 100 amps through that cable. And it's not a 100 amp limit, really. That's the ratio. We could do 200 amps. There's really no current going through this device. It's going through the cable. But as you can see, the size of the cable you could put this around would be not capable of any more than that anyway. So it's a ratio 100 amps to 50 milliamps. If you have 10 amps, you have 5 milliamps of current output. And so this is how we're going to measure power. And with this chip and what we know about power factor and phase angles, we can not only calculate the true or active power and frequency, but we can tell its direction. We can put a sign on it. And putting signs on things is kind of a 50-50 shot. I always use positive values because I see the world as a battery, and my relationship is as a battery to the rest of the world. A positive value would be in to the battery. That would be like solar production. And a negative value would be a flow out of the battery. We're subtracting power from the battery. From the battery's perspective, that would be a negative, a discharge. And so that we'll call that negative. And we can put a sign on power flows of AC power. Why are we going through all this? Well, as I've described, This is a new chip. It's better at measurement. Again, this is a collaboration between me and Colin. I actually picked this chip out, found it online, read about it a little bit, and said, man, I'd like a device that would do all that. And the chip won't do it by me waving it in the air, so let's, they have Analog Devices sells a reference board, test board, for about $342, I think. But we want to do something else. And this goes to the heart of what's wrong with all these companies and what they're doing. They want your data, they want access to your wireless network, and there's a lot of reasons why you might not want either one of those. But the sin I fault them for is they don't publish their communication protocols. I don't care that they have intellectual property in their firmware. That's fine. I could disassemble their firmware, believe it or not. I started programming in assembly language. The higher level languages I considered for girls for many years. But I've come around. C++ is okay. Still don't do Python very much, but I could if I wanted to. The problem is we need to use this information, and we don't necessarily want it out of the building with us. But I do like wireless, and our ESP32 is working out very well. We've kind of developed, and I won't say we invented this, but we do a lot of it. I didn't really get it somewhere else, but I'm sure others have thought of it. We use user datagram protocol packets on a wireless network to carry CAN messages. It's just, since we do so much CAN anyway, it's easier to simply replicate the CAN wirelessly by taking the same frames and putting them in user datagram protocol, UDP packets. And we kind of simulate a CAN bus by broadcasting that on the 255 subnet address, the last address of your typically 192.168.1, and your device is .110 or .120 or .140. .255 is reserved. You can't put a device on that. That is a broadcast address, and if you send something to that address, all devices on the network get it. Now, I actually had a guy, some days it's great to be here. He actually criticized me for sending UDP packets of 24 bytes apiece on the broadcast address and wasting bandwidth in my local network I've bought and paid for at 24 bytes per packet. And he was commenting on a video he'd just downloaded. It was 4.8 gigabytes into his wireless network. But he was noting it's very inefficient to use the broadcast address with 24 byte UDP packets. Maybe we'll buy a bigger router if it gets to be an issue, Pard. My point is, everything he was saying is true, and it absolutely doesn't matter. We've moved straight out of 1985 into 2019, where we're doing 4 or 5 gigabyte videos. A 24 byte packet is, I don't know what it is. It's not anything. It's so little traffic, it doesn't matter. And the little home routers now have gigabit internet, Ethernet. We used to discuss whether gigabit Ethernet was possible, theoretically. Packet data at a gigabit rate. Could it be done? That was the conversation in 1986, 87. Now home routers have it. So I don't want to hear that putting UDP packets or CAN frames on the broadcast address is a problem. Not if you're watching our 4.8 gigabyte video where this thought struck you. That's like, it really tickles my sense of whimsy. But anyway, this is, everybody's got a opinion. In any event, this is the board we've been working on. Colin, of course, did the board layout and the library to access. Well, they actually provide an Arduino library. We modified it heavily, and it's on Colin's GitHub thing, but it makes it a lot easier to access all of this. And I'll show you a little bit of the software that we're doing it for. Why do we want to put the data on CAN frames over UDP? Well, we may not be located at the main circuit breaker panel. This device has to be. These two transformers, these two things have to be there to make the measurements. You can't do it anywhere else. But our peak shaver or our time shifter or even our PowerSafe could be in the basement or in the garage or in the shop or in another room in our case. And so we need to have access to that data. This device will measure it and transmit it, but it doesn't really do anything because there's nothing I need to do at the circuit breaker panel. We did actually put 6 instead of 4 of the MOSFET switches on here so that you could turn 6 relays if you wanted to manipulate a bank of, 6 different solar inputs or something. We built that in for future use, but I'm not sure just what the use would be. But we've got them on there. I run up against the 4 limit quite a bit on the other stuff, and so we put 6 of them on here. So we have 6 switch ground MOSFETs that'll do a couple 3 amps a piece, enough to turn on even a large Gigavac contactor and hold it. And then this ADE9000 chip that does the measurements of voltage and current and actually calculates, again, active power, apparent power, reactive power, volts RMS, the current on each phase, and power factor, total harmonic distortion, and frequency, all in one chip. And the difference, what we're after, I may not give you the software that runs on the controller, but will of course publish our communications interface, which can be over CAN or it can be wirelessly over UDP, and you'll certainly be able to interact with it. In other systems, and they don't have to be our systems, we will have this package where it is a power monitoring device that is open in connection. You can get onto it with USB and get data. You can get onto it with CAN bus and get data, wired twisted wire CAN wiring, or you can simply monitor a UDP port, and you get to configure which UDP port, and we'll publish the packet description of what each byte means as far as these values. And so it's going to be kind of an open concept for communicating with it, with several methods that you can do that. And if you want to put it on a website, I'd love you, that's great. We'll ultimately probably get a version of our display working with this if you just like pretty lights and stuff. But for us, we're going to use it as the input power measurement for a peak shaver or a time shift device. This being wireless, we'll also go out and get a time mark, and so we can do things by time of day and so forth to handle some of those sorts of things. So this is a piece, I can't really do a peak shaver if I don't know what the power load is. And my peak shaver may not be at the main panel. And so we wanted a device that would measure AC power and transmit it wirelessly where other devices could use it to monitor how much grid power you had coming in, or in our case, even with the Ciganair and the PowerSafe 100, we have a 15 kilowatt limit on what power we can put out. If we had another device that was a grid-tied inverter with batteries, like the Danfoss I just described, we could use that to produce power as well and extend our power maximum. And in fact, we could use, because they're grid-tied inverters, we can use as many grid-tied inverters as we want, using as many or few batteries as we want, and in this way extend the power ability of this situation. And we don't have to cable them like stringing radians together or something. We can simply have them work automatically based on power levels, but we don't want to be taking it out of one battery, running it through a grid inverter, and back in through our Ciganair inverter into another battery. What's that about? And so we need to be able to switch those on and off based on our knowledge of the output power of the PowerSafe. And that, by the way, is exactly the same situation as a peak shaver would need to do with the amount of power coming out of the grid and the wall. And so this is like a key component to make all that work, and a bunch of other stuff as well. So it's not quite as elegant yet as a Sense. Doesn't have the gigaws and web things, but you can add those. I can add them later. The basics is you'll be able to measure it and access it. And be able to communicate it in a way, and you can like go a completely different direction with different batteries, different equipment, different inverters, whatever your design is. This has a very specific application. It can monitor power, it can tell the direction of the power, and it's an open interface. You can get the information several ways. And so the recommended way is simply to monitor a UDP port for CAN packets, CAN messages that will be available to everything that's on that network. And so we think this is going to be a big addition. It may not make much of a splash, but it enables us to do some things that will. And I'm raving about peak shavers. Trust me, you're going to like that term sometime in your near future, even if you don't do solar. You're going to be looking for a way out of those peak demand charges. And this is it. I'll show you a little bit of the screen that we have with this, and you'll see a little bit of what I'm talking about, the measurements. I would warn you that the ability to measure is the ability to become confused at some level of accuracy. you understand that your fluke meter, a lot of these things massively average their readings before presenting them to you so you don't go blind. I'm not going to bother with that. We can sort all that out in software. We want it as quickly as we can get it, and it be as accurate as possible. And that there's a lot of variations in your power line. You'll be surprised to learn. Voltage isn't precisely voltage, and current isn't precisely current if you have the ability to read it at a certain resolution. There's also, in any device like this, some calibration. We have some calibration factors that you can change. It's pretty hairy to do so, and you change it to match what? A fluke meter works for me, but you may want to get out an oscilloscope and get it really down to a gnat's ass. That's up to you. The device will do it. The calibration factors can be directly entered. I'm working on a little auto-cal thing where you can simply enter a meter reading and it'll seek that recursively by successive approximation. But that's what's going on there. Again, let's take a look at the screen. Okay, what we're looking at is our ADE9000 AC power monitor. This is a new board we've made from the ADE9000 chip, which is a relatively recent chip to monitor 3 phases, voltages, and so forth in an AC power system. And we've adapted it to do 2 phases and 2 voltages. And it automatically calculates apparent power, active power, reactive power, frequency, power factor, total harmonic distortion, etc. And I've written a little program here to do all that and accrue kilowatt hours as well. It does use our Wi-Fi to transmit this data in kind of UDP packets. Let's see here. They're really CAN frames, and we transmit them on the broadcast address .255 as a user datagram protocol 24-byte CAN message. And so we can mount this device near our loads panel and connect it with some voltage and current sensors, and it will tell us how much power. Positive or negative is the big thing right now. We're producing positive power from our solar edges and from our in-phase, and that is going into our battery system to the tune of about 8,150 watts of power at 59.995, power factor 99.32, and a total harmonic distortion of 8.96. We package that data all up into some CAN messages, transmit them using the user datagram protocol, and we broadcast it on the 255 address in our subnet. And what that is anything on the same wireless hub can receive or monitor that port, a UDP port, and receive this data. And you'll see why that's important here in the near future. But we can measure currents, voltages, volt amps is our apparent power, and our active power, true power, is in watts, and this other data. And we will transmit that wirelessly into our environment, and other devices can then use it. We have a second screen here. I'll call up. Let's turn off our debug display. And here's where you enter your wireless information. We're transmitting on port 6560 UDP, again at that broadcast address on our hub. And this is our currents, but these are our calibration numbers. And so we can use those, we can modify those to calibrate these outputs and compare that to measurements made with fluke meters and other meters to ensure its accuracy. And so this is our calibration screen, and this is our viewing screen. All this is sort of test setup. Our purpose is to measure current and voltage and power at the panel, and then to transmit that into the ether where we can have other devices that can monitor it. Why would we want to do that? This is shown positive right now because it's going into the battery. It would appear negative if it was coming out. And for example, in a peak shaving situation, if we had a negative power coming out of the batteries of our 15 kilowatt inverter and it got up to 12 or 13 kilowatts, it would be nice to turn on a grid tied inverter that may be on another battery, which we'll call our peak shaver, and that it would augment our output power of our Ligonier inverter with some grid tied inverter output from a battery to handle that peak load. And we'll talk more about peak sharing and time shifting elsewhere. But we need to be able to measure the power coming in from the grid or coming out of our Ligonier off-grid inverter in order for any of that to make sense. Enough about me. Let's talk about Tesla. The wider media has discovered a process in covering Trump that is egregious, I think, and is a huge mistake for them. They'll basically forfeit all of their audience before it's all over. That is simply make up stuff, hoping that some small percentage of their viewership doesn't know any better. The latest on Tesla is being applied to Tesla now and Twitter and Google and almost anything experimentally, and it seems to be having the same effect. Some small percentage is convinced of nonsense. The latest is that Tesla's Gigafactory march to completion has been suspended by Panasonic and Tesla because they're not selling enough cars. This is absurd on the face of it. The much ballyhooed disaster quarter one, it is not even a disaster. The first quarter of the year is always lower sales combined with the decrease in the subsidy. They took a little bit of a hit. Actually, it was far less than I or probably Elon Musk even imagined. They're crushing it. The Gigafactory has been a huge success. Tesla's vertical integration is part of what makes them unassailable by normal automobile manufacturers. They are going to slow the expansion of the factory because right now they don't need the space. It has nothing to do with car sales. It has to do with what we discussed earlier, the acquisition of Maxwell Technologies. Recall I discussed these huge, long, complicated, expensive, noxious drying ovens that they have to run their foils through to dry the electrode material on them. This is a nightmare. Maxwell has a dry coating electrode process that eliminates that and allows hundreds of feet of battery cell production line to simply disappear. The result is Tesla has much more space than they actually need now as they move to retool the Gigafactory to produce Panasonic battery cells using this dry coat technology. And so there's an incredible savings. Their battery lines will be 10% of the length of what they are right now to produce the same number of cells. It's an astonishing improvement just mechanistically. The process also introduces a number of new variables in optimizing the battery chemistry itself, with the polymers and the percentage of that, the amount of exposed crystalline structure, the conductive additive, and so forth, the heat of the rollers it goes through, the speed it goes through, and so I expect to see some somewhat dramatic, or at least notable, improvements in the batteries themselves, while speeding the production of them. But a byproduct of all this is a very handy, almost complete diminution of space you need to produce a battery cell. And the battery cells continue to be the constraining issue with Tesla. The Gigafactory expansion, I'm sure, will continue at some point, but right now it's simply not that much of an issue because they're going to move to different cell manufacturing equipment, and it's going to take up a lot less space. Meanwhile, they are under construction of a second Gigafactory in China, and the pace of that building project is simply astonishing. They only started on this a month or two ago, and it's they've got steel going into the air, foundations poured. It's they're claiming they'll be able to produce cars there, Model 3 cars, by the end of 2019. The one thing we know historically is that won't happen. It's a target that Elon Musk is pushing everyone to achieve, but I would be astonished if they produced a car by the end of 2019. That said, I think you would find that at completion of this factory, when they do produce cars, it will be the fastest construction of a car factory in the history of the world, ever, by anybody, at any scale. And this one's going to be a kind of huge scale. So the Tesla continues to just simply crush it. The other announcement right now that has got everyone in the Twitter is about Autopilot. And as you know, I've been agnostic on Autopilot. It's not that I don't believe in it, it's that I question how easily it could be done. So far, my summon mode at the house is comical to play with. Again, it opens doors sometimes and others it can't. It still can't find the correct song on the radio. And so all that artificial intelligence so far to me is underwhelming. But the story is very good. And now Tesla is rolling out the Model 3, or the electronic control unit version 3 computer for this, which I ostensibly will receive for free, having purchased all Autopilot options when I bought my 3 in February of 2018. And he is claiming that Autopilot will be feature complete by the end of 2019. Now that's somewhat carefully worded. There is an element to autopilotism that is kind of out of his control, and that's regulatory approval. And it kind of has to be approved either federally or in all 50 states, or I don't know exactly how that regulatory approval is going to be played out. His claim is that there'll be a 2 or 3 X improvement, or 2 or 300% improvement in safety, or decrease in the number of accidents. And their main forte in Autopilot is their ability to collect data. They can collect data over GSM, much like their over-the-air updates on autopilots, when they've been disengaged and when the car's been in an accident and so forth. Now at an astonishing scale, there's nearly 500,000 Teslas on the road, and 300,000 or 400,000 of them are reporting almost continuously whenever they're being driven. And for neural net artificial intelligence activities, having a vast amount of data is simply requisite. It's the coin of the realm, and no other car manufacturer is simply able to generate that kind of data. Against the background of Lyft's IPO and Uber, the success there, and actually Uber has now come to our little town of Cape Girardeau, and people are finding these ride-hailing services extremely popular. If you look at ride-hailing with just electric instead of burning gasoline, it becomes an entirely different thing economically. You're not purchasing gasoline. That you could hail someone on a specific network, hail a ride, and get to ride in a Tesla is all by itself a big deal. If you hail a ride through Uber or Lyft, God knows what the guy shows up driving. It could be a dump truck. I mean, they have some rules and requirements, but Tesla's talking about a Tesla ride-hailing network of their own. This is kind of going to be, again, a 10x disruptor of the field, because you could hail a ride using your phone app and get to ride in a Tesla, which is going to be a premium, nice car, and it's sort of guaranteed. Tesla doesn't make old beat-up cars. The economics of it change just by it being electric. But then there's more. With Autopilot, Musk is seriously talking about having your car go pick someone up without you going with it and taking them where you want to go. And he even has a camera in the car that's now explained, so you have a video recording of the people in the car during the ride. So if there's any damage to the interior, you have evidence of it and can have them prosecuted. And so this adds an entirely different element to it. Then Musk has announced a 3-year lease on Model 3s, and this again increases the kind of affordability of the car. Now understand that Nissan did this with disastrous consequences. It essentially terminated their electric vehicle program, although they continue to sell them. But the cars were sold on a very attractive lease, and they had no takers at the end of the 3-year lease period because they had already upgraded the cars. And why would you want to buy the one you're driving when you could get another attractive lease program on a brand new one? This is a rapidly evolving technology, and lease programs simply don't work. The result was a huge flood of very discounted Nissan Leaf used car prices, which actually made a new car from Nissan, despite the improvements, unattractive. We described this several years ago and actually advised some of our viewers to don't build an electric car. You can buy a Nissan Leaf for $9,000. Why would you do this? I can't sell you the batteries for that price. And so Musk obviously has picked up on that. But they have rather a different plan. You're not going to be able to buy the car at the end of 3 years. So he's not going to have to worry about the conversion rate because there won't be any. Tesla's going to take the cars back. Well, what are they going to do with them? Well, Elon Musk is kind of a control freak. Yes, there'll be a Tesla ride-hailing network, and yes, you as a Tesla owner can participate in it, but Tesla itself is going to operate Tesla Model 3s in a ride-hailing network, and that's what they're going to do with the off-lease Model 3s. And so they're doing a rollout presentation of this April 22nd, which is just a few days from now. And you won't want to miss that one. For one thing, Musk has been talking about a driverless cross-country trip in a Autopilot Tesla by the end of the year for 2 or 3 years. And I assume he would not be doing this rollout unless he had that in the bag. And I would go further to predict that you will probably see the car roll in somehow timed to show up after having driven from New York or some other godforsaken shithole country as part of the stunt, and arrive at the announcement of the event that he's going to hold April 22nd for about Autopilot. And so if Tesla can pull off Autopilot in any way, it steals a march on all other automakers, on all other ride-hailing services, and represents a totally disruptive economic transition of simply unheralded, unheard of disruption. And Lyft and Uber will have primed the American market, certainly, but really worldwide, to the advantages of ride-hailing, but Tesla will be the one doing all the driving. This is simply enormous. I can't get my head around what that would mean. Can Autopilot operate well enough? Well, my experience so far has been not. I have some, and watching it try to get out of the garage. My phone can't contact the car when it's 20 feet from it half the time. It'll open the garage door and back out, and then it can't close the garage door. It's just comical. However, his mission of having a car 3 times safer than the average human driver sets a pretty low bar, as evidenced by the number of Teslas on Copart. So, for all of us, it is an interesting thing. If an imperfect autopilot can reduce the number of accidents by a factor of 3, it becomes attractive for everyone. And he actually predicts a day when it won't even really be, people won't quite be able to picture how in the back in dark history, people were allowed to drive 2-ton hardware around that's completely dangerous themselves without an autopilot computer. And I guess I buy into that vision. But it's a hard nut to crack. If anyone could do it, it would be Tesla. But the progress I've seen so far is very minimal. I am anxiously awaiting the update where I can do the parking lot summon anywhere within 150 feet, and we'll see how that goes. But I hope it's more functional than what I have now, just getting the car out of the garage. In any event, the future for Tesla is enormously bright and on a huge number of fronts. And batteries is one of them, and Autopilot is one of them. And what you're being told on the screen that I can see is it's not a little bit wrong. No one can be that stupid. It has to be deliberate. They can't simply miss this. Now, my wife insists that I simply underestimate how stupid people can be. But this has to be malevolent. They simply can't be that unconscious to be reporting what they are, the way they are, given the facts evident. Stay with us. There'll be more EVTV.